Hello everyone, and welcome back to Liftoff. Mars has been under NASA's radar for quite some time now. Their main goal is to find out whether the planet is habitable for mankind to live there. To understand more of the red planet, the space agency has sent a bunch of rovers to the surface to explore and study everything they can, ranging from the soil to the atmosphere and even the climate. In addition to that, the agency has been utilizing a bunch of satellites to study the planet's atmosphere. Since the rovers landed on the planet, scientists have learned quite a lot about the planet. However, something out of the ordinary happened recently, proving that the planet is not dead after all. Sometime in May of this year, there was an earthquake on the planet. However, this was not an earthquake like any other. It was the largest one ever recorded on another planet. This Marsquake, since it did not occur on Earth, had a magnitude of 5.0. This event was recorded by InSight, the lander that has been taking notes on Martian seismicity, weather, and orbit since 2019. This Marsquake occurred on May 4, 2022, and it is the strongest event ever to be detected on another planet. Not only that, but it is also the maximum of what scientists expected to observe. Before we can learn more about this Marsquake, make sure you smash that like button as hard as you can and subscribe to our channel for nothing but the latest news on Elon Musk, SpaceX, science, technology, space, and so much more. And with that, let's find out more about this Marsquake. The Marsquake happened just a few moments after scientists released some details regarding the previous two largest Marsquakes, which occurred in 2021. It was as if Mars just overheard the scientists talking and decided to give them something to talk about. In 2021, there were two large Marsquakes. One occurred in September with a magnitude of 4.2, while another one occurred in October with a magnitude of 4.1. These Marsquakes are discussed in a new research paper in the Seismic Record. They are also quite important as they give clues to geologic activity on Mars. NASA's InSight mission, which stands for Interior Exploration Using Seismic Investigations, Geodesy, and Heat Transport, consists of a lander serving as a geophysical research station that is near the equator of our neighboring planet. The rover is equipped with two cameras, a weather station, a seismometer, a heat probe, and communications equipment. This is the first ever project of its kind to take place. Before this one, there has never been seismic equipment on another planet. The main goal of this mission is to learn more about Mars as scientists try to understand how Earth and the other rocky inner solar system planets were formed. Scientists also hope that the mission will shed some light on the origins of similar planets that are further from our neighborhood. InSight's seismometer officially went online in February of 2019, and it was carefully positioned on the surface of Mars. By October 1, 2021, InSight's instruments had already recorded a total of 951 Marsquakes. Scientists are trying to use these quakes to determine estimates of the size and nature of the core, the mantle, and the crust of Mars. So far, some models describe how fast the seismic waves travel through each layer, and with the new information that is being sent over by the lander, these models are constantly improved. All we know is that there is a series of Marsquakes that takes place on the Martian surface, but what we do not know is how they are recorded. One thing is for sure, they are complicated to sort through. The equipment is set on a softer, wind-altered material. Because of this, the lander sends back noisier signals that would not even be recorded on Earth. Anna Horlstone, a planetary seismologist at the University of Bristol and co-leader of the InSight Marsquake service team, explained the process. She said that the very first step in deciphering Marsquakes is looking at the levels and patterns of the different energy frequencies. This is for them to separate the wind signals from the potential Marsquakes. Most of the wind signals are nearly continuous during the day, making the sharper seismic signals easy to pick out from the weather activity. Most Marsquakes are classified by the frequencies that are recorded for that event. The distinguishing frequency is mainly 2.4 Hz, since it is easily affected by seismic activity. Events that are below 2.4 Hz are said to be low-frequency events, while those above are said to be high or very high-frequency events. According to the researchers, frequency is how fast the ground ruptures during one of these Marsquakes. Slower ruptures are said to give off lower frequencies, while faster ruptures mean higher frequencies. Most of these quakes are named after the day of the mission, which is when they occurred. If multiple events happen in one day, they are differentiated with letters. For the first 975 days that InSight spent on Mars, no Marsquake was greater than a magnitude of 3.8. However, on August 25, 2021, which is known as Sol 976A on Mars, there was a low-frequency quake with a magnitude of 4.2. The seismic energy from this quake was felt throughout the planet for more than an hour, which has been the longest quake ever to date. The second Marsquake, dubbed Sol 1000A, was described with a new study that had a magnitude of 4.1. It took place on September 8, 2021, and had a span of frequencies that have never been recorded during a single Marsquake. This makes it harder to pinpoint the origin of this September event and even harder to unravel. Data from InSight suggests that the primary wave, the first signal to arrive at a seismic station, traveled to the boundary of the Martian core and mantle, another novel observation. If you were to compare it to here on Earth, when seismic waves reach the liquid outer core, the change in material causes primary waves to bounce back at a new angle, blocking any secondary waves from continuing at all. Given that this is the first Marsquake to get to this region, Sol 1000A will provide data that will help the scientists estimate the distance to the core, its size, shape, and even phases. According to Anne Horrelston, Sol 1000A was a unique event. The fact that we see all of the high frequencies suggests it had a fast rupture. However, she does say that the cause and location remain a source of debate. Most of the earlier Marsquakes have been identified by InSight all originated around Cerebras Fossae, which is a fault system that formed about 10 million years ago. However, for the recent quakes, they are different. Sol 976A is linked to Valles Marineris, which is just south of the equator and much farther away. The Valles Marineris is one of the largest canyons in our solar system, being about 4 miles deep and 2,500 miles long. According to the paper, other researchers have suggested that the Marsquakes in this area are based on the faults and slides that are very visible at the surface. So because of this, Sol 976A is under close study as scientists try to understand the processes that may occur in the Valles Marineris region. However, the region of Sol 1000A is still not clear, but it can be linked to the same hemisphere of Mars. Anne Horrelston and her colleagues are trying to use a new approach to help them better understand the locations of these quakes. They are trying to use the polarization of the signals to look at the angles at each phase of the seismic waves that they can identify. They will also look at the area's geology for clues about what caused the big quake, now that they have a better idea of where it started. As exciting as these quakes are, given that they were the largest Martian quakes at the time, they are also very perplexing. The InSight mission is still ongoing even after its anticipated duration of 1 Martian year, which is roughly equivalent to 687 Earth days. According to Horrelstone, as seismic data keeps coming in, such as the one from the quake that occurred on May 4th, the team is still working to integrate the data from these major quakes to improve the velocity models, along with the estimates of the radius of the core and the distance to the mantle. From the record-breaking May 4th event, scientists can also learn more about the Martian core shadow zone and how seismic waves travel below the surface of the planet. The location and the cause of this latest quake, along with any other subsequent ones, will definitely take the mission team some time to unravel. In addition to that, it will also build on the analysis of Sol 976A and Sol 1000A. Feel free to let us know what you think about the massive quake that happened on Mars on May 4th in the comment section below. Also, before you go, make sure you smash that like button and subscribe to our channel for nothing but the best and the latest news on Elon Musk, Tesla, SpaceX, science, technology, space, and so much more. Thanks for watching, and I'll see you next time.